So here again, we've returned now to continue calculations, and we are at the Radisson JFK airport this morning doing our application of the PDM in circuit analysis problems, basic engineering circuit analysis, and we have specifically chosen some 3-mesh problem. We're going on to some 4-mesh problem later, and we're going to be introducing some complex parameters as inductance, and other things which will bring on vector quantities and magnitude as well as angles in these calculations. Phase angles and scalar as well as vector. Okay, so we are calculating now. Well, my pen has popped out here. Let's see if it's writing still. So we say now that Ni1 was equal now to, we replace voltage value of this one, which would be equal now to 960, 0 and 0, minus 5, plus 7, 0, minus 3, 0 and 4. And that would be the determinant of that. And as we find Ni1, we now say now that I1 was equal to Ni1, which is 96, 0, minus 5, 7, and 0, minus 3, 0, and 4, over the determinant now, delta. And delta was equal now to 8 minus 5 minus 3 minus 5 plus 7, 0, minus 3, 0, and 4. So that will give us the I1 value. All right, let's find I1. Let's find I1. So, all right, let's say, we find the determinant, which is Ni1 over delta. We say that that's equal to 960. That is Ni1 equal to 960 into 7004. That's equal now to 960 multiplied by 28 minus 0, and plus now 0 times another matrix, that will give 0, and plus 0 times another matrix, that will give 0. So this, we could leave out these two and know that this will be the answer here for Ni1, and so let's see if we could find something to calculate this thing very quickly. 28 multiplied by 96. Calculator. Calculator. We say no 28 multiplied by 960 equals 26,880. So that is Ni1, the numerator value. And now we find now delta, the denominator value. And delta is equal now to the determinant of this. And we say now the delta is equal now to 8 into 7004 minus 5 into minus 5, 4 minus 3, 0 minus 3 into minus 5 minus 3, 7 and 0, plus 0 into that will drop out, plus now 7 into 8, 4 minus 3 minus 3, 8, 4 minus 3 minus 3, and then minus 5 into, we're finding delta now, minus 5 minus 3 minus 3 and 4. That's minus 5, right? Minus 5 minus 3, 0 and 4. So this is supposed to be 0. And 0 is neither positive nor negative. Therefore, if you subtract or add it, it doesn't have no value on the outcome. And what we are now, minus 3 into 5 minus 5 plus 7 minus 3, 0, and 0 into this matrix that will drop out, and finally plus 4 into 8 and 5, 8 minus 5 minus 5 plus 7. So that will give us the value for delta. And so we see now that's equal to 8 times 28 minus 5 times minus 20, that will be a positive value there, minus 3 times, now 0 and 5 is 0, so that part will drop out. And this is what? 7 plus 7 and 3, that is minus 21, but you're going to subtract that, so you get a plus 21 and plus 7 into 8 4 is 32, and 3 3 is 9, so positive and then a negative, that's going to turn into a negative, and minus 5 into 5 4 is 20, minus 20, and that one is 0, and minus 3 into that 0, that's negative, so it turns into positive, plus 21, and plus 4 into 8 7 56 minus 25. We'll quickly do that calculation there, and that will give you the value of delta. Okay, as we come back, we'll use our calculator and calculate the value of that. All right, let's say that using our calculator here. Clear. 8 times 28, 8 multiplied by 28 equals, that's equal now to 224, and this is 100 plus 100, and that is now minus 63, and this is now 32 minus 9 is 23. 30 from that will be 21. We have 23 times 7. Um, 23 multiplied by 7 That's plus 161. 5 times 20 would be plus 100. 3 times that would be minus 63. And 4 times, which is that, 56 minus 25 would left us with 31. 5 from 6 is 1. 31 times 4. So 124. And doing it mentally, let's try from 124, we say. Total 1 multiplied by 4 equals 31 multiplied by 4 equals 124. And this is now plus 124. So we're going to add that, and that also gives us the value of delta. So that's 124 plus 224 plus 100 plus 161 plus 100 again. Minus 63 minus 63. And that's equal now to 583. And therefore now we say now that I1 then is equal to 583, and therefore I1 was equal now to n I1 over delta. That should be equal to, we get n1 to be equal to 26,880 over 583. And let's do that quickly to get the value of I1. And note that that will be a positive value so that the assumed direction of the current is right. So I have now 26,880 divided by 583. 583, that's equal to something is wrong here. 461. Okay, let's see. 26,880 divided by 583 equals 46.1063. 46.1063. 46484648 halves. So we get the value for I1. We come back and calculate I2 and I3.